Hello, and welcome to Backer Breaks It Down. Today's episode is the vertex of a parabola. So we're going to talk about what the vertex is, what's happening at the vertex, how can we find it. We're also going to look at vertex form of a quadratic function. Vertex form, that's what the function h is written in the graphic on the right, the whole like negative 0.6 times the quantity d minus 3.6 squared plus 3.6. That's vertex form. So let's talk about it, okay? So just remember, quadratic functions, we call their graphs a parabola. So normally a parabola has a vertex here at 0, 0. That's like standard position for a parabola. Now they can be concave up or concave down. The a value will tell us what's what. So if a is positive, it's concave up, and negative, it's concave down. This vertex, you can think of it as the turning point on your parabola. Now, it's at the vertex where you'll either have a maximum or a minimum. Once again, this is dependent on that direction of opening. So if a is positive, the function opens upward and has a minimum at its vertex. And if a is negative, it opens downward and the vertex is a maximum. Now, the y-coordinate of the vertex, that's what we refer to as the maximum or minimum value of the function. And then the x-coordinate tells us like where that value is happening. It's also through the vertex that the axis of symmetry passes through. So the axis of symmetry is a vertical line. It's passing through the vertex of the parabola, and it divides the parabola into two symmetric parts. Okay. So when we're working with vertex form, generally we're using h and k to represent the vertex of our parabola. Now, vertex form is also that transformational form. Now, we've studied graphing transformations in the past. They kind of tell us whether there's been any vertical size change to the graph, whether the graph has been shifted right or left or up or down, and then would also indicate like reflections, because you might have a negative out in front indicating a reflection. But vertex form is this transformational form, and it tells us where the vertex is located. So the vertex is at the point hk, right? So vertex form is that transformational form where the function is equal to a times the quantity x minus h squared plus k. The vertex is the point hk. Now, I want you to be careful when you're identifying h because of the subtraction. We always have to be careful whenever the x's are involved. Okay. The axis of symmetry is the line x equals h. That a value is going to tell us which way it opens. So if it's greater than 0, it opens up and therefore is concave up. And if it's less than 0, it opens down and therefore concave down. This will also impact our range, because range are our y values, low to high. And then the y-intercept, as always, can be found by evaluating f of 0. So plug in 0 for x and calculate. Do be careful when you're identifying what h is, because the function like formula is written using x minus h. If we see x minus 3, that means h is positive 3. Or we're x plus 3, h would be negative 3. So we have to be careful whenever we're identifying those h values. So let's take a look at example number 1 in your notes. Okay. So for the parabola given by the function, f of x is equal to negative 0.5 times the quantity x plus 6 squared minus 4, states the coordinates of the vertex. So the vertex will be that point hk. Give the equation of the axis of symmetry. The axis of symmetry is that line, x equals h. Find the y-intercept. We're going to do that by evaluating f of 0. State whether it's concave up or concave down. That will all be dependent on the a value. If it's positive, it's concave up. Negative is concave down. And then also identify the range. I think a simple sketch is best there. We'll talk about that. So taking a look at this particular function, I guess we should identify like h and k. So in this problem, h would be negative 6, k is negative 4. We always have to be careful with our x values, but like that k value is going to be fine. So our vertex is the point h comma k, so we're looking at -6 comma -4. The axis of symmetry is that line x equals h, so we're looking at x equals -6 for this particular problem. For our y-intercept, you want to evaluate f of 0. So we want to literally plug in 0 for x and calculate. And you can do the whole thing in your calculator. Okay, that's what I usually do. I got -22. Concavity, well, that a value is -0.5, so it's going to be concave down. Now for the range, you can refer to the rules up above, or I think a simple sketch works best because it's like, I know my parabola opens down and I know that my vertex is going to be at that maximum point there. So -6, -4 is the vertex. And for the range, I want to write down like my y values, and I want to think, how low does it go? How high does it go? So this parabola here would go low forever, so I'd write -infinity. And then it would go as high as -4, and it is solid there, so I'd use a bracket. So I can write my range in interval notation like this. I could totally use the inequalities. This one would be like y, all my y values are less than or equal to -4. Okay, either way works for me. So what's going to work for you? You need to decide that, okay? But we use the y-coordinate of our vertex to find our range. And so that's vertex form of a quadratic function. Good name, since you can very easily identify the vertex from it. Just be careful when identifying h, since it is written x minus h. And that's how Backer breaks it down.